Hi, welcome to my math blog. Today I'm going to do a problem regarding integration by parts. So when you have the product of two functions and you can't use substitution or some other way to take the integral, then we can use, a lot of times, integration by parts. So here's the formula that we use, and here's an acronym that helps us to decide what to choose, which function to choose as our u. So this is LIATE, is how I like to say it, and it stands for logarithmic, inverse trig, algebraic, regular trig, and then exponential. So like if I've got an integral and it has an exponential function and an algebraic function, well, I'm going to choose the algebraic function as my u because it's first in this little acronym. Alright, so let me go ahead and move this acronym to the side so I can refer to it later, and we will start to solve a problem. Alright, L-I-A-T-E is LIATE. Okay, let's start with this integral. We'll say the integral of e to the t times t squared dt. Okay, so right off the bat, I can look at this and say, if I try to use u substitution, I'll say u equals t squared, then my derivative of u, du, is going to be t. Well, okay, I can't use u substitution. I can't split them in two because it's two functions multiplied together. Aha, I'm going to have to use integration by parts. Okay, so then, what's going to be my u? Well, I'll just look right over here at LIATE. Do I have a logarithmic function? No. Do I have an inverse trig function? Also a negative. Do I have an algebraic function? You bet I do, and there it is. That will be my u. So u equals t squared. du is going to be 2 times t. Don't forget the dt. Okay, now we need to find dv and u. Well, dv is just whatever's left over plus the little dt. Not added to, but also coming along. So, what's left over is the e to the t, our exponential friend, and then a dt. So, before I go any further to find, well, while I go further and find my v, I am going to take a look and remember about this function e to the t. So if I have a function called y, and it goes, and its rule is e to the t, then that tells me that the derivative of that function is just going to be itself all over again. If it happens to have, let's say we have e to the f of x, then that says that the derivative is going to be e to the f of x times f prime of x. Okay, excellent. Now, if I want to know what the integral of this thing will be, so let me go ahead and integrate. I integrate u. If I integrate the derivative of a function, what do I get? I get the function. So what does that tell me? It says that the derivative and the integral of e to the t is in fact e to the t. Okay, another method to find out what your v is, you can say to yourself, what function has a derivative e to the t, or the derivative of whatever's here in the dv spot. Also, you can just take the integral of dv, and that will give us back v plus c, because it's unbounded. And don't forget the dt here. That points off on your test for that. Alright, so then, let me go back up here. I have my v. It actually is e to the t. So it looks like we may have an easy time of doing this. So let me use my formula. This guy up here, I will rename him h, just because I'm going to write h equals, okay, now I'll use my little formula. So u is going to be t squared times v, that will be my e to the t, minus the integral of v, e to the t, du, which will be 2t dt. Okay, so it looks a lot different now. It is simpler. However, we can't do anything with this either. This is pretty much another situation where we're going to have to use integration by parts. And when I say pretty much, I mean absolutely. Okay, sorry. So then, what can I do? Well, first off, let me remember that everything on this side, let me factor out this 2. Okay, get you out of there. So I'm going to factor out this 2, and let me make a note that everything, whatever the result of this integral is going to be multiplied by -2. So this is a point where it's very easy to get the signs mixed up. Let me rewrite that so that it doesn't look all crazy. So, okay. So what am I doing? I'm factoring out that 2 that was a constant. And so, since I've done that, the whole result of this whole integral itself that we ended up with, e to the t times t dt raised to, is going to be multiplied by this -2. Okay, what do we have to do now? We need to find another u, another v, another du, and guess what? Another dv, exactly. So u, in this case, let's see, we have an exponential function. That's at the end. What about this? Yes, this t is algebraic, so we will use it first. So u equals t, du equals 1 times dt, that's right. What about dv? dv is whatever's left, and also I don't know which to use, equal signs or, let me get consistent here. Consistency is important. So the dv is whatever's left. We already used the t, so we need to use et, phone home, to the dt. Alright, now we've got to go up here to a v. What's our v? It's the integral of dv, which is just, as we previously discovered, et. Now, let me look at the camera to make sure that all of these things are legible and that you can see them on the screen. Okay, so far it looks like we have a big mess, but we don't, because now we're getting very close to a solution. So let me erase up here. I'm going to erase all of this because I'm going to rewrite the problem now in its new form. Okay, so remember we have h here. So h was our original integral, so h is equal to t squared times e to the t. Okay, I'll put this -2 right here, and then a parentheses, because remember what I said earlier, if we don't do this, it's very easy to mix up the signs and get confused, but the result of this integral is going to be a product with this negative sign that's acting on that too. Okay, so what do we put in here? We use our integration by parts formula again, which is u times v minus the integral of v du. Okay, so then we have a u and a v. Excellent. Here we go. U is t, and v is e to the t from home. Alright, now, subtract from that the integral of v du, and so our integral now is e to the t times dt. Okay, look how close we are getting. We only have one integral left. This is going to be a happy day because we will be finished with this problem. Okay, so as you can see, we just have the one integral left. Do we need to use integration by parts on this integral? Anyone? Anyone? Bueller? Bueller? Okay, no. The answer is no, we do not. So what do I do? Well, okay, the answer is e to the t, right? So let me just go ahead, because we've already done this integral like twice when we were doing this problem. This marker doesn't want to work right. So what is our solution? Our solution is, I'm going to go ahead and rewrite h now back in its regular form. So e to the t times t squared dt equals t squared times et minus, okay, 2 times t times e to the t, okay, minus a minus plus this integral, so just in case you didn't catch it, the integral of e to the t dt equals, in fact, e to the t plus what? Plus c, don't forget that, that will make you lose some points. So minus a minus plus e to the t, wait, I've got another 2, right? E to the t, and then of course, don't forget the c, plus, actually, plus c is what we'll say. Okay, but actually, because it's a plus c here, it should be a minus c. So it could be a minus c, but it doesn't really have to be, because if you have a constant, so this constant could be like anything, minus 2c. Because it's just a constant, it doesn't matter. We can just write c regardless. So, okay. So the c equals negative 2c. So this c is our constant of integration. So now we have solved our integral. Are you happy? Are you pleased? Because we are finished. Oh, and since we're done, maybe we can make a little square. Maybe? I don't know. That's a little fancy math. But anyways, integration by parts. 2 things you need to know. Vate, and of course, uv minus the integral v du. Some other helpful tips. The integral of dv equals v. Alright. Okay, and then don't forget the parentheses and the subtraction signs and all this. So I'm very happy to say that this concludes this video. Please, if you have problems or questions, send them to mathproblemsolvednow@gmail. And like, if I get like thousands of emails, which I probably won't, or even like 20, I won't be able to do all of them, but I will do at least 1 or 2 of them a week, and I'll post them on a blog. And also, if you need a tutor, go ahead and send an email to that same email address. I do tutor private sessions at the university or at libraries, just wherever is convenient for you. Okay? And hopefully, if you have a question, I can answer it, and you have a great day. That's what you want to do now. Now that you've done your math, have a great day. Okay? Goodbye.